So welcome to the first meeting of the year for the Triangle SQL Server users group. This is our advanced DBA subgroup. Tonight we're doing a little bit special because it's totally remote only due to our normal venue being double booked, but that's all right. We have with us an outstanding speaker tonight. I'm going to hand it over to Edwin Sarmiento, whose name unfortunately I didn't actually get the correct pronunciation of beforehand, so I'm totally winging it. And hopefully I did not mangle Edwin's name too badly. As far as announcements go, no major announcements. We are still working on venue for SQL Saturday Raleigh. I'm hoping that we're going to be able to do it in April. Had some trickiness with a couple of the locations that we wanted to go to, so we're going to keep working on it. I'll send out new information when we get it and update the Triangle SQL Server users group news and notes. That was my one announcement. Now, excuse me. Now I'm going to fight my post-flu symptoms by muting myself and handing it completely over to Edwin.
Thanks a lot, Kevin. I was actually laughing. Good thing I had my microphone on mute when you said, now for our announcements. We actually don't have any announcements because it reminded me of when my son was around 4 or 5 year old, and he was doing a lot of these videos. You know how kids are nowadays. Like, they do review videos, like, unboxing something. And at one point I hear him doing a recording. Hey, what's up, everyone, and welcome to my review video. And today I don't actually have a video to review. It reminded me of that time. And it's a good thing that I got my microphone muted. Otherwise you'll probably hear me laugh. Good evening, everyone, and welcome to this presentation on building a custom SQL Server on containers image for faster deployment. I had to put that in there just in case you're not aware of who I am. My name is Edwin. I don't usually say my last name because when people... And by the way, Kevin, you did it really great. So long as my mom doesn't hear people say it, I'm fine with it. Microsoft Certified Master for SQL Server. I was a Microsoft MVP for 12 years. My key area of expertise is on high availability and disaster recovery, with special focus on SQL Server. The reason I got into Dockers and Kubernetes and that aspect of the DevOps space is because of how Microsoft's really driving a lot of these move towards open source and Linux and Kubernetes. In fact, if you look at how the market is going, specifically Microsoft, because they invested a lot in running SQL Server on Linux, now it's all about, let's push it forward and make it Kubernetes aware. And if you've seen a lot of the announcements from the past summit where they introduced Azure Arc, that entire platform is running off of Kubernetes. But in order for you to really understand what Kubernetes is, you have to understand what containers are and what Dockers are. Now, I do have a couple of, not a couple, but just one survey question, because this is more of a advanced DBA group. I do have one question for you. Why did you decide to join today's presentation? I mean, you can type your responses on the chat window. The reason I ask is because Tuesdays are a great time of the week, to, relax a bit. It's the first presentation of 2020. Can't believe I'm saying 2020. It's the first presentation of the decade, if you kind of think about it. So why did you decide to join today's presentation? You could have been at home, or, you could have been watching your favorite Netflix series. I don't know, maybe enjoying a great dinner with family. But why did you decide to join today's presentation? Type it in chat. I want to get a feel of, what your goals are. People attend user group meetings, presentations, conferences. They do have different goals. And my goal, the reason I ask this question is I want to understand where you're coming from, what your goals are, and in joining today's presentation, and what you expect to take away from this, right? again, type in the chat window, and I'd like to hear from you. But I do have a couple of assumptions moving forward with you on this presentation. Number one, you have an understanding of containers. That's one major assumption. Number two is that you've been working with SQL Server for a while. You kind of know your way around SQL Server. You kind of know the basics, like reading data pages and reading stack dumps, if you call that basics. So those two main assumptions. I'd like to assume that you have an understanding of how Docker works, but I want to set the stage right and paint a picture of why I came up with this presentation. In fact, this is one section of the book that I'm writing, and the idea behind this is, when you go to a store and you want to buy something, say you want to buy a shirt, and you don't really like any of the shirts that are available on the store, you either go to somebody who can come up with a custom-made shirt that you really want according to your size, your measurements. And the same thing when you're deploying a database solution or a database platform like SQL Server. You might not like the default settings, or you may have a specific set of corporate policies or security requirements that you have to meet, so that when you're deploying your databases, you're meeting those requirements, and you could custom build your own environments. So again, those are kind of like my assumptions here. I want to start off with the concept of DevOps, because again, the developers are doing so many things in the DevOps space that we database administrators are kind of losing track of what they're doing. In fact, I've been working with a couple of clients and customers, and I'm seeing a trend. The developers are way ahead of whatever it is that they're doing. And, they're starting to take over deployment of databases, be it just a change in the schema, entire database with data. They may not know anything about databases, but I know one thing's for sure: they're taking over our jobs. And so for us, it's important for us to understand what they're doing, where they are, what tools are they using, what practices are they using, because we're the ones supposed to be responsible for databases, and we need to make sure that we're applications connect to the database properly and we deploy them the right way. So let's start off with DevOps. What's this whole DevOps thing? I grabbed this definition from Amazon. And it's the combination of cultural philosophies, principles, practices, and tools. It's not one, but a combination of all of these. I hear a lot of people say, "Oh, DevOps is kind of like Agile. It's kind of like we're using a couple of different tools." It's not. It's a combination of these, with the goal of increasing your team's or your company's ability to deliver applications and services at high velocity. I know there's a lot of terms in there, but simply put, it's evolving and improving products at a faster pace than using traditional software development processes. And when you think about that, you're thinking, wait a second, the database in itself is part of that development process. In fact, which is interesting, because even before this whole thing was called DevOps, I've been doing DevOps even in the mid 2000s, and all it was simply making sure that we are getting our work done quick and fast in an automated fashion by following certain philosophies and principles. In fact, part of our team requirements when hiring a new engineer is having that mindset of automating things to make sure that we're not spending a lot of unnecessary time repeating stuff that could be automated either through tools or scripting. And that's what this whole DevOps thing is. And when you think about this concept of containers and Docker, the idea behind this is, we're not just introducing a new technology. A new technology is useless if it's not solving a problem. In fact, let's just backtrack a bit when it comes to, the challenges we faced first off with physical machines, which is interesting because, just a decade and a half ago, we were deploying physical machines. We would rack and stack machines in data centers and server racks, and then we are installing operating systems, we're installing applications. Of course, in that case, SQL Server is the application. We're doing a lot of these things, but the biggest challenge that we had back in the days of the physical machines was the fact that we are guessing. And what do I mean by guessing? Well, we need to roll out a new project, and then your manager would ask, how much CPU memory and disk I/O and network bandwidth do we need? And we kind of like, I don't know. It's a new application. Which is kind of ironic because we call ourselves data professionals, yet we are guessing. When you deploy a new machine, you're over provisioning, right? You'll never know how much CPU memory, network, and disk I/O resources you would need to just over provision everything to a point where you're spending a lot of money buying stuff that you don't need for workload that you're not even sure of. And this is a big no-no for people for the bean counters. But the idea behind why virtual machines came into place was because of the fact that, hey, I can't just be guessing. Because I don't want to be buying a very expensive HP DL380 and sitting on my server rack and, only 20% of the time is being used. And so out comes the virtual machines where you're installing a hypervisor on top of this physical machine, and I can deploy as many virtual machines as possible on those physical machines. So now we're not just deploying hardware and not maximizing them. Although the flip side of this is we've abused virtual machines to the point where deploying and over provisioning virtual machines and not even thinking about scalability, high availability. We're just going to throw as many virtual machines as we can on a physical machine. But again, going back to the idea behind the whole Docker thing is we're not just introducing a new technology for the sake of technology. It has to solve a major problem. So what do containers solve? What problems do containers solve? And when you really think about it, it's simply this. It's to reliably run software when you're moving from one computing environment to another. I mean, when you think about it, yeah, virtual machines do solve this problem a bit. When you're moving from physical to virtual or from virtual to virtual, but of course, I can't really move a VMware virtual machine to a Hyper-V host because now you're moving to a different computing environment. Oh, not to mention, if I want to deploy applications on my development environment, I want it to look exactly like how it would look like in production. Only problem is, of course, I need to, tweak, the infrastructure for production to take into account surges in resource utilization throughout, its life cycle. And again, this is the whole concept behind why containers were introduced. And when you look at, comparing virtualization versus containers, let's have a look at the hypervisor architecture. You're looking at a physical machine, you got your hardware, and you're installing a virtualization layer, your hypervisor, your VMware, your Hyper-V, your Citrix. And on top of your hypervisor, you're installing or you're creating a virtual machine. And the idea behind a virtual machine is you are virtualizing the hardware. On top of the virtual machine, you're installing an operating system, and then you're installing an application on top of it. And you can run as many virtual machines on top of a physical hardware, so long as your underlying physical machine can handle the additional resources. In contrast, containers look something like this. So you look at the container architecture. So we start off with hardware, same thing. But instead of having a hypervisor layer, we have the operating system. Now think about that. In the hypervisor architecture, we are creating a very thin layer between the physical hardware and the virtual machine. In the container architecture, we are directly running on top of the operating system. On top of the operating system, we create a container, and then we install the application on top of the container. And when you think about it, it's a very lightweight version of an operating system. And then you can run as many containers as you want within your operating system. Now you might be wondering, well, why do we need the container architecture? When you look at the hypervisor, it created a totally different set of problems. For one, we spent a lot of time patching the OS, securing the OS, managing the OS. But when you think about it, we're not in the business of managing, patching, securing an operating system, right? We're in the business of, again, when you look at what we really do as a business in general, we are in the business of providing value for our customers. Now, we as DBAs, our job is to provide value to our customers, internal customers, that is, applications connecting to the database, and provide more value instead of spending more time, resources, and money maintaining operating systems. So in the container architecture, you have one copy of the operating system, and you can run as many containers, just like virtual machines, as many containers on top of that operating system. So those containers, the idea behind that is it's a Linux concept. When containers were first created, they were created, of course, by Linux developers for Linux, until eventually Microsoft decided to embrace it, incorporate it into Windows, and now we have Windows containers. But the idea behind this is it's virtualizing the operating system. Unlike virtual machines where it virtualizes the physical hardware, a container virtualizes the operating system. So instead of having multiple copies of the operating system, you have one operating system. Instead of having multiple redundant copies, you only have one. Imagine how that looks like when it comes to storage, when it comes to footprint in your deployments. You don't have multiple copies of the operating system, you just have one. But because it's virtualizing the operating system, a container needs to have the same operating system kernel underneath in order for it to run. Meaning, if I want to deploy a Windows Server 2016 container, I can't just run it on a Linux container host. It has to share the same operating system kernel. It shares the host's kernel, like I said. All of the containers will be accessing the same operating system kernel. And that's the importance between, if I want to deploy a Linux container, it has to be running on a Linux host, because the container will have to use the underlying host's operating system kernel. It uses the kernel's ability to group processes for resource control. Think of it as isolating different processes and grouping them together so that they can be managed as a unit. And then they feel like lightweight VMs, but they're not virtual machine. Some people call them, virtual machine 2.0. They're not, because again, a virtual machine is virtualizing the physical hardware. Here you're virtualizing the operating system. Which also explains why in a virtual machine world, you can run a Windows, a Linux operating system on different virtual machines in the same host, because you're not virtualizing the operating system. You're virtualizing the physical hardware. In contrast with containers, if you're running a Linux machine, you're running a Linux operating system, you gotta run Linux containers on top of them, right? You may have read some of the documentation from Docker that tells you could run both Windows and Linux containers on the same machine. That's partially true, because you need to switch context in order for you to do that. You cannot simultaneously run a Windows and a Linux container in the same physical machine. Now, how does Docker? I mentioned Docker. Docker is the standard de facto technology when it comes to containers. There's a lot of different container runtime engine out there, but it's kind of like Red Hat for Linux. Red Hat became the de facto Linux operating system just because they captured the market earlier. It's just like VMware when it started. It was the de facto virtualization platform. And Docker has this way of running containers in its platform by using all of these different components in the ecosystem. First off is the Docker client. It's a command line interface that you use. And I did mention command line interface because the idea initially was created. It was created with Linux in mind. So you got to be very, very comfortable with working with a command line. If you've been using PowerShell for Windows for a while, you'll be fine with this. It's just a little bit of a challenge for DBAs who have not been working with the command line and moving into containers, and now they're forced to learn a lot of these command line commands. There's always an opportunity for you to learn not just Docker, but Linux in general. Because there's a lot of Linux constructs, whether you're running off of a Windows container or a Linux container. But again, you have your Docker client and your Docker daemon are kind of like your service in Windows. Your Docker daemon is the one that's running the service, and it's the kind of like the service that runs containers. So let's say you execute a command. Let's say I want to run a container. The client will reach out to the service or the daemon, an API call. The daemon will first check, hey, what are you trying to do? Oh, you're trying to run a container. Wait a second. Do I have a copy of that image? And I talk about image because that's the whole topic of tonight's presentation. Do I have a copy of that image locally, meaning in my storage subsystem? If it doesn't, the first thing that it will do is it will reach out to a public container repository and pull that image in the repository, store it in its storage subsystem locally, and then use that as the reference point for running that container. Once the image has been pulled, it now is used for succeeding containers that you run. The thing about this is you can run as many containers as you want based on that image alone. Think of this as the virtual machine golden image. You create a golden image, and then what you do is if you want to deploy a virtual machine with certain characteristics or certain configuration settings, you create a golden image, and then you create a VM based off of that golden image. This is how Docker runs containers. It will constantly look at files and file systems and images stored in a local file system, and then it will only pull the image once. Once the image is already available locally, any container that you start or run will be based off of that. What was that? The thing about this is when you compare starting a container versus starting a virtual machine, big difference in terms of boot up speed, because number one, when you're starting a virtual machine, you're booting up an entire operating system. When you're starting a container, there really is no boot up time because the operating system is already running. You're simply starting or running a container. So it's a split second difference versus, depends on how long it takes for you to start a virtual machine, depending on the operating system. And so think of that for a second because it affects how fast you start a SQL Server instance inside a container. Now, I mentioned images and containers. right? I mentioned pulling down images from a public repository. I mentioned creating and running containers. What's an image and what's a container? An image is a read-only template for creating application containers. This is kind of like your golden image when you're creating a virtual machine. You install everything that you need in a virtual machine, and then if you want to create machines using those applications, you don't have to recreate everything. All you have to do is create a new virtual machine based off of that template. Your containers, and this is your runtime instance of an image, right? Kind of like the object-oriented analogy. You got an object, and then you have a class. You can create multiple instances of an object from a class, and your class is like your image, and your object's like your container. But to really understand this, because I mentioned a thing about file system. An image is simply a set of files structured in a file system layer. Now, that file system layer, I like to think of this as Lego pieces. When you're creating something out of Lego, you got different pieces and you put them together. An image is kind of like that. Every file system layer will have a set of application files, operating system dependent files like libraries, anything your application needs in order to start and run a container. Keep in mind, this is your golden image. This will be the basis of every single container that you're going to run. Because it consists of file system layer, when you see something like this, and I'm going to show this to you later in a demo, is when you see something like this, you see different layers, file system layers. And let's imagine how this image is built, right? There's the first layer. Maybe this is the layer that contains, the dependent files in order for the container to run, operating system dependent files, right? The second layer, maybe this contains files that you need. By the way, I'm referencing a SQL Server on Linux container image here. Maybe this contains the files that your operating system needs to download or pull the SQL Server installation packages from Microsoft. Another layer maybe contains information about new users being created. Another layer maybe contains permissions and so on and so forth, right? As you're building this 1, 2, 3, 4, 5, 6, 7, 8, 9 layer image, once the image is built, it's locked and marked as read-only. Now, the beauty about this file system layer is, how we're updating and installing patches on a SQL Server instance. When you're installing an update, let's say you're moving from CU 8 to CU 14, you're basically adding files to an existing SQL Server instance. Where you're installing updates for a VM, for a physical machine, you're basically adding files to it. Now think of it this way. If I'm moving from SQL Server 2017 with CU8 and I'm installing SQL Server 2017 CU14, I don't have to build everything from scratch. All I have to do is add that one layer in order for me to have a new image, a new picture. Like I said, an image is simply like, bits and pieces of Lego piece that you're piecing together. If I want to add on top of that, all I need to do is find a new layer maybe and add it to it. This is your image. And our goal is to create a custom image based on what you need. Customizations are there. Your user databases are there if you want to deploy it for your development environment. Additional files are there if you're adding configuration files. This is our goal.
So we have a question along those lines here, which might be a little bit early, but what is the database size limit in a container, or best practices around maximum database sizes for images?
Great question. So it's a typical question that I get a lot when it comes to containers. So what's the maximum size limit? And the thing is, remember what I mentioned about the concept of container was first created with applications and the Linux operating system in mind. In addition to that, containers were designed to be ephemeral, and I forgot the other word I was thinking about, which means anything you store in a container is temporary. It's unlike the way we dealt with VMs in the past or machines in the past. I want an update, install the update, and keep that VM, keep that machine as long as we possibly can. In fact, that's probably the reason why, migrations and upgrades are very complicated, because you never know what's in that existing machine, right? In contrast, containers were designed in a way where here today, gone tomorrow, which means the way it's designed is that you're never supposed to store anything inside a container. So how do we deal with stateful applications like databases? Because initially the containers were designed for stateless applications like web servers and application servers and APIs that don't store data. Well, the answer to that is creating volumes. Volumes, you can look at them as mount points in Windows. They are visible from the point of view of the container, but they don't actually live inside the container. They could be, anywhere. It could be an NFS mount, a network file share. Again, just like how you would deal with volume mount points. So a follow-up to that is, so what's the size limitation of the database that I can store, or size limitation in general? Well, the size limitation is always dependent on the size of the underlying storage infrastructure. I remember the time when I worked with a client. They're a big media company in the West Coast. And we had this goal of migrating an entire data center. They had one of their data centers is in Los Angeles, and we're moving it off to one of their Las Vegas data center. And we had a downtime of 4 hours in total. And as I was reviewing the configuration setup, the first thing that I saw was, wait, these are all physical machines and we don't have any drive other than C? Like, that's a complete no-no from a database point of view, right? Everyone will tell you, don't ever put your databases on a C drive. I was about to tell them that until I realized, wait a second, the databases are never in the C drive. They were using NetApp as their underlying storage subsystem, and they mounted LUNs on the C drive. And this is a very good example of how containers are designed or deployed for stateful applications like databases, to a point where we managed to migrate the entire data center in less than an hour, because all of the databases are stored on their NetApp storage subsystem, and they were all being replicated over to different to the second data center. And all we had to do for the migration was to stop SQL Server, detach the LUNs, connect to the target data center, reattach the LUNs, and start SQL Server. Boom. In less than an hour, we managed to accomplish the whole data center migration. And again, going back to that question about how data is stored, it is highly recommended, even if it's dev tests or especially production, to store your databases in a volume mount point. And I'm going to show you a demo about that in a few seconds, since you already asked that question. Store the databases on a Docker volume. So when you're creating your databases, they're not stored in the container. They're being stored inside the volume. So you could wipe out your container, delete the container, replace it with a new one, but your databases are still there, right? You're storing your system user databases in there. It's the whole concept behind separating your compute versus your storage, right? Now, to continue on with this, a container is simply a new layer, a read-write layer, running on top of the read-only layer. And that's why it's pretty quick when you think about it. It's a very thin read-write layer. All of the bottom layers are not modified. They're not changed. Again, totally opposite, complete opposite of how we've dealt with systems and servers in the past. In the past, hey, I want an update. Install the app, install the patch, install the whatever you need to install, and now we have a new VM. In the world of containers, you're not updating the container. What you do is you create a new image with the updates, and then you deploy a new container based on that new image. So you're not stacking and adding and changing and modifying anything in the container. You're simply changing the bottom read-write with a new one, and then storing your databases on a Docker volume, right? So before I move on, like I said, I'm going to show you a little bit of Docker. I've got two systems here. One is a Windows Server 2016, and one is a CentOS Linux, because I don't want to pay licenses for Red Hat Enterprise Linux. I pre-pulled all of the images that I'm going to need for this, for the demos. So on my Linux machine, I have 4 images, 3 of which are SQL Server on Linux images. 2017 SQL Server 2017 GA. One has the SQL Server CU14, and the other has the CU18. And I have an extra one that is just the base image for CentOS 7.6, right? On my Windows machine, I've got 2 images that takes a while to display. The first is a Windows Server 2016 Server Core image running SQL Server 2017 Developer Edition, and the other one is a Windows Server Core 2016 with the latest updates. If you look at the size, I don't really like looking at the Windows sizes. 11.1 is the size of the Windows Server Core 2016 image, whereas on a Linux machine, if you look at the base CentOS image, it's 202 meg. The SQL Server 2017 Ubuntu image is 1.4 gig. I rarely show how to work with containers on Windows because of the size. I mean, imagine trying to pull a 15 gig size file from the Microsoft Container Registry or the Docker Hub. But let's get started with some introduction on some of the commands. Remember what I mentioned earlier about, hey, I want to run a command on a Linux machine or my Linux Docker host? If I'm trying to run a container and the image that is referenced by containers does not exist, it will pull that image from a public container repository, store it in a local storage subsystem, and then use that as a reference for starting the container. So I'm going to run the Hello World version of Linux on my Linux machine. And what's interesting is the Hello World container pretty much tells you exactly what I just told you earlier, but in text. Docker client contacted a Docker daemon. Docker daemon pulled the Hello World image, and in fact, you would see this message says unable to find Hello World latest locally because I don't have it. Pulled that image from the Docker Hub, which is the public container repository. Once it is complete, it ran the container, and this is what the container had. Right? Now I could run a SQL Server on Linux container. I'm going to use this. And what I'm going to do is I'm going to use one of the images. I don't have to pull anything. I'm going to replace this one with this. So I'm going to use the Ubuntu, or rather the one with CU14. SQL Server 2017 with CU14. I'm going to use that. Image. Now watch this. Okay. What I'm trying to do here is I'm trying to run a new container. -E, I'm just passing environment variables. You probably know what this is. It's the I accept user license agreement parameter in your configuration INI file on SQL Server. This is your SA password. -B, I'm simply mapping the host port number, which is the one that we're going to use for SQL Server, to the container port number. And I'm just going to use 1433 here just to make life easy for me. I'm going to call the container SQL-linuxcon01 -D. I want the container run in detached mode, meaning once I run the container, I'll let it run in the background. -H stands for hostname. I want to call it Linux SQL01. And the image that I'm going to use will come from mcr.microsoft.com/mssql/server colon 2017-cu14-ubuntu. If I run this command, done. The container is up and running. I want to connect to it using SQL Server Management Studio. 140, yes. And now I can connect to the SQL Server on Linux running in a container. And I can run Docker PS to look at the status of my containers. Been running for 31 seconds. I'm using port 1433, and it is running the SQL Server process, SQL Server, just like the SQL Server.exe, and still waiting until this thing is done. That's interesting. Let me see if something went wrong with this. There we go. What you're looking at here is SQL Server error log. This is SQL Server error log. It's probably the reason why it takes a while for me to connect to the database engine using SQL Server Management Studio, because it's doing an upgrade. Let's try that again. Yeah, the upgrade process isn't done yet. And there you go. If you look at the SQL Server Management Studio image in the background, it's now complete. That's probably the reason why it took a while to get SQL Server Management Studio connected. Now I'm running a SQL Server on Linux container on top of a CentOS Linux Docker host. Oops. If you look at the properties of this, it will tell you that I'm running Ubuntu 16.04. Wait a second. I'm running on a CentOS machine. Why is my container running on SQL Server on Linux, on Ubuntu Linux? Version. Let's say the results in text. There we go. And you can see here it's running on Ubuntu Linux 16.04.6. Didn't I mention containers are simply they're simply virtualizing the underlying Linux or underlying operating system kernel. Now, in this case, whether you're running on Ubuntu or CentOS or Red Hat or SUSE, they share the base kernel. The only difference is the specific Linux flavors implementation of the Linux operating system. And so the base layer that that the image uses is simply a deviation from the underlying Linux kernel. Now let's try that same example using our SQL Server on Windows image. Run the exact same thing and run it on my Windows machine. Copy. There you go. Same command, same Docker run command, same parameters, except for the name, because I don't want to get confused, except for the name and the image we're using. Here we're using the SQL Server 2017 Developer Edition on Windows Server Core, because you can't run a UI with containers. Because the idea behind that is it's supposed to be running as a service, and you're not supposed to be logging in directly. So there's no such thing as a UI. Plus Linux, So we can connect to the Windows container as well. Once it's done, 2016 Docker. And I'll use the same password for the SA login. Oh, by the way, the only reason I was using host name for the Windows versus IP address for the Linux is host files. I didn't update my host files. This one connects directly to the Windows machine using the host name versus the other one is using an IP address. So we're waiting. Yeah, that's going to take a while. So I've shown you how, a simple Docker run command would create a container based on an image. If the image isn't available locally, it will pull it down. And once it's pulled down, you can run as many containers as you want on that, using the underlying image as your reference. Now, here's the thing, though. Let's see. Okay. Done. And you can see this one is running Windows Server 2016. Might as well just that. You can see that I could run as many containers as I want. I could run another one. Let's change this to, because I can't use multiple containers with the same port number. Maybe 1423, 02, 02. I want to run this. MCR dot. I remember the name of the image I'm working with. There. Go. So what I'm simply doing here is I'm creating a new container based on the existing image. We'll call it 02, 02, 1423. And that's it. Done. So now I can create and connect to it. But now I'm going to use port 1423. I don't know why I thought of 1423. But it's a port number that I am not using at the moment, so I'll just use that. And connect. So now I'm running multiple SQL Server instances on the same host. Like I said, you can run as many as you want using that one base image. But didn't I mention that these are all default images that Microsoft provides? Maybe you don't want. Oh, interesting. Maybe you don't want. Maybe you don't want to work on the default images. Maybe you want to create your own images. Let's see. Oh, the other one is still getting upgraded. Right. So what if you you want to create your own? Maybe you want to add. Maybe you want to add user databases as part of it. So going back to the question earlier about, so how do we store like user databases, or what's the size limit? You don't store user databases inside their container. You create a volume, and then you mount the volume to your container. How do we do that? Yeah, I'm still waiting until this thing completes the upgrade. Let's see. So I'm showing you the Windows container this time. If you look at the Windows container, it's running SQL Server 2016 Developer Edition, running on Windows Server 2016 Data Center Core. Right? Versus the other one is running on Windows Server, rather SQL Server 2017 with CU14 on Linux Ubuntu Linux. Okay, so as I mentioned, you don't really you don't store. Well, you could store your user databases inside the container. The only problem with that is, well, if your container goes away, your databases are not going to be there, right? The idea behind that is you want to persist the data. We're database administrators. We're database professionals. We want to store. We want to keep them. We want to make sure that the data stays intact. And the way we do this is by creating volumes. I'm going to use a Docker volume command to display all of my available volumes. I don't have any at the moment, so I'm going to create one. Docker volume create. I'm going to call it SQL DB data. I now have a new volume named SQL DB data. Right? And SQL DB data, this new volume, is stored under this directory over here. File Docker volume SQL DB data. Well, I can do the same on Windows. I can create a new volume on Windows, and then it will be stored on a default directory. Now that directory could be, a mount point, and that mount point could be pointing to, a high-speed storage subsystem, maybe a tiered storage subsystem for that matter. So let's create a volume. So far, I don't have anything in here, so I'm going to create a new volume. And if you look at where this is stored, it's under E, MNT, Docker, volume, SQL DB data, and underscore data. Like I said, your E drive could be on your SAN, could be on a network file share, it could be a mounted volume. Right? And then you mount the volume to the container that you're going to run. So let's do this. And I'm going to change this so that I don't have to type everything. And my tag Right. So here's the command that I'm running. It's the same command, except in this case, I am defining a mount using the --mount source SQL DB data. This is the name of the volume that I just created, and then the target var opt MSQL. By the way, this is the default directory that SQL Server is installed on a Linux subsystem. So what I'm simply saying is I'm mapping the default SQL Server directory to my SQL DB data mount point or volume. Okay? Just like how you would create a volume mount point on Windows and have that volume mount point pointing to anywhere. We're simply telling the container, hey, anytime a file is added to var opt MSQL, I want you to store it here. Okay. I'm going to use that image. I'm going to call it SQL LinuxCon 05. I'm going to use port 1133. And there we go. All right. Now let's have a look at that directory that we just created. What is that directory? That directory is var lib docker. Okay. I'm going to switch to root because I don't have root privileges at the moment. I'm going to switch to root and then navigate to that directory. I'm going to go ls list this directory. And I got data, log, and secrets. Those two folders look very familiar. Let's go and dig deeper into data. And we see master, model, MSDB, tempdb. And by the way, these are all stored in the local host, meaning the Linux Docker host. It's not inside a container. So let's do this. Let's connect to that SQL Server instance. I'm going to be using port 1133. And I'm going to use password that I just created. Keep in mind, if you look at the properties of this new SQL Server instance inside a container, it will tell you, the default settings like the storage, the database files, the backup folder, all of that. And here it says your data and your log files are inside var opt MSQL data. Let's create a database. New query. Sample test, sample DB. Okay, I'm just going to take all the defaults. Oops, database. Typing so fast. The database has been created. If you look at the database properties, your files are inside. Oops. var opt MSQL data. But did we configure the container to store var opt MSQL data or var opt MSQL and anything inside var opt MSQL in the volume? So let's have a look at the underlying operating system. Now I've got two new files, your data and log file for the sample DB database. In this case, I could afford to delete the container. Docker PS. I can afford to delete this one. I'm going to stop the container. And I will delete the container. and look at my data, and the database files are still there. Again, the concept behind separating the compute from the storage. What you're looking at here is the storage. I just completely whacked out the compute object, the container itself, and it's gone. Right? And what I could do with this is, let's say I'm updating from CU14 to CU18. I'll just create a new container with the same host name, different container name, of course, different host, same host name, same port number. That way my applications can still work, but now I've upgraded my container. I just walk you through some of the the fundamentals of how work with SQL Server on containers, but that's not the main topic we have. We want to build a custom SQL Server on container, whether it's a Windows container or Linux container. Because like I said, these containers that you're seeing, they're from Microsoft. They may have configuration settings that you don't like. One thing that I don't really like about this is the fact that this is running on Ubuntu. I want to standardize on Red Hat Enterprise Linux or CentOS. I want to standardize on that because Ubuntu is for developers. I'm kidding, because I just don't like Ubuntu. It's a preference, or maybe there's a standard in your company where you're deploying SQL Server databases on a specific platform, and you don't necessarily want the ones that are available from Microsoft. So let's have a look at building your container or your custom container image. Okay. The way this is done is by creating a file called the Docker file. The Docker file is simply a text file. It's a text document, and what it has is it contains all of the commands that you could run on the command line to create a custom image, right? Think of it as you performing a series of steps, running commands in order to create an entire platform. For instance, if I want to build a Windows Server 2016 running SQL Server 2017 with Service Pack 2, and I want to do that all from the command line, what do I do? Right? There's a couple of things that I need to do. I'll walk you through that. But imagine trying to build a platform from start to finish, and every single step, every single command that you're going to run are all going to be run using the command line. The one annoying thing that I don't really like about the Docker files, for one, it has to be spelled a Docker file with uppercase D. Can't be lowercase, has to be uppercase. And it's not supposed to have an extension file name. So if you're using Notepad, like what I've been using, and you don't put quotes on your when you're saving the file, it will automatically add a .txt to the file. Docker file does not need a .txt. It just has to be Docker file, uppercase D, no extension. Okay, let's have a look at a Docker file. And what does the Docker file consist of? It consists of several of these commands. The first one is the from instruction. The from instruction is the first instruction that your Docker file needs to have. It defines what your base image is. Now, the base image could be, the base image for an operating system. It could be the base image of something that's already available. Let's say you want to use, this. You want this image to be the starting point of your custom image. In your from instruction, you just specify whatever that image is. Because I like building stuff from scratch, just like, again, creating a golden image. I want to keep things as clean as I possibly can. I don't want to I don't want to add files that are not necessary. In fact, I like my systems lean and efficient. to a point where I don't even want to install Management Studio. I don't even want to install anything other than the SQL Server database engine on my machines. That's kind of like my standard. Here we're starting off with an image CentOS 7.6.1810. I don't like Ubuntu. That's the very first instruction for my Docker file. Next we have the labels. Labels are simply a way to add metadata to your image. You can add as many label instructions as you can. Think of this as an additional documentation. I like the idea of having as many information as I can on documentation because I love documentation. Said no one ever, right? But here, coming up with information that you can add or metadata on your Docker file makes it easy for people who are going to use your image. Give them an idea of what's in that image. Who's the maintainer? I like the maintainer because if somebody goes wrong, it's the first person that they get in touch with, right? What version of the operating, or rather, what version of the image, what version of the operating system, and so on and so forth. Okay, so that's your label. I've seen cases where people don't actually put label instructions, and because you could have comments. But for me, it's just good practice to let someone else understand what this image is for. Next, we have the run command. The run command is simply telling the image, I want to run this specific command. Now, I've got two commands here. One is curl, which simply is pulling the repo file. And a repo file in a SQL Server or in a Linux system is simply the definition from where you want to pull or download the package from. It's kind of like, using your mobile phones. You don't tell it, hey, go pull it from, the Microsoft or the Apple website. No. Using your Google app or your Apple Store, you simply, tell it, hey, I want to download this. The app contains the repo file where the packages are stored, so you don't have to tell it, hey, I want you to download it from the Microsoft website. So that's run. The second, the one-liner way of installing SQL Server on Linux, because I'm using a Red Hat variation. I'm using yum install mssql-server is the name of the package. -y is simply saying go answer yes to all of the prompts during the installation, kind of like an automated installation. And then we have the env instruction. Env is kind of like your environment variables on Windows. Here, I'm simply telling the Docker file, look, anytime you see a command and that command is not explicitly defined, meaning the path is not explicitly defined, I want you to use this particular path. And it's opt msql bin. This is where the SQL Server on Linux executable is stored. This is the default directory where the SQL Server executable is stored. You see another set of run commands. Here I'm simply creating, using mkdir, I'm creating a folder named var opt msql data, and I'm also changing the permissions and ownership. Yes, no, permissions of the var opt msql folder and the etc password folder, and assigning it the permissions that my MS-SQL user. In fact, part of this is actually creating the MS-SQL user in the Linux subsystem. Expose is simply exposing the local port number that you can use to connect to your container. And finally, CMD, or command. It is what I need to run inside a container. Typically, it's the application. In our case, it's SQL Server. And because we're not providing the explicit path, the env instruction is telling the Docker file, look, We want to run SQL Server or SQL Server from this path. You store all of this information in a Docker file, save it, upload it, or store it on your Linux Docker host, and then build that information, build the Docker file or build the image using this Docker file. Okay. How you do that is you run the Docker build command. -t is the tag for the image. I'm going to call it SQL 2017 CentOS. I'm going to call it version 1.0. The dot here is the relative path. I'm assuming that the Docker file is in the exact same directory as where I'm running the Docker build command. This dot could be anything. You can provide a manual, the absolute path. In my case, because I'm lazy, I'm just going to provide the relative path. So let me go back to my Linux host, and I want to show you an example Docker file. Like I said, it's a Docker file, no extension file name or no extension file extension. It's a text file. It's simply a text file, uppercase D, Docker file. Let's see what's inside a Docker file. It's exactly what I showed you. From instruction, it tells me the base image, label instructions, the run command or run instruction. I want to pull the repo file for my SQL Server on Linux package, and I want to pull that from this location. And then I want to install SQL Server using this command, and then define the environment variables using this path. That's why here when we call the CMD or the command instruction, I didn't have to provide the explicit path where the SQL Server executable is. So I'm going to copy this over to my Linux machine because it's in my Windows machine at the moment. I'm going to use WinSCP. I got WinSCP here. I want to create a new folder. I'm going to call it Docker build. And what I'm going to do is I'm going to, let's see, stop. I'm going to copy my Docker file into this folder. And all I need to do is navigate to that folder. Currently, I'm under root, by the way. I want to switch to my my account. I don't want to be logged in using root as I'm doing this. CD. And there you see my Docker file. Okay. It's the exact same file. And now I'm going to build my Docker file, which means I'm going to create a new image based on this Docker file. Keep in mind, I only have like 1, 2, 3, 4, 5 images at the moment on my Docker host. Okay. So I'm going to create a new one based on a CentOS base image. I'm going to install SQL Server 2017. And I think it's EU18 that's going to install. And I'm going to create that image using this command. I want you to pay attention to the different outputs. Step 1 of 13 from CentOS. Then you see a GUID value, which was shortened. It's supposed to be a 64-character GUID value, was shortened to 12 characters. And then step 2 of 13, label. And then you see at the bottom of it, it says removing intermediate container. So what this is doing at the moment is it is piecing together your layered file system. What it's doing is it is creating an intermediate container and running the command or running the instruction that you specified inside the Docker file. Once that step's done, the two are merged, intermediate container is deleted, and the new one's created. And that's why you see all of these step 1 of 13, 2 of 13. And when you look at the Docker file, you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 lines. And that's representative of step 1 of 13 because it's going through 13 instructions. We're currently at instruction number 7, where it's pulling, or instruction number 8, where it's installing SQL Server at the moment. Of course, this would take a while. It would install SQL Server, and after installing SQL Server, it will, expose 1433, and then it would run the SQL Server executable. The thing here is if you're building a Docker file, or if you're writing a Docker file, you want to make sure that the last instruction is the one that runs your application. In our case, SQL Server is our application. And the reason for that is if, let's say you're running a command and the command completes, if the command completes, then there's nothing running in the application and it will terminate. You want to make sure that the last instruction that you define in your Docker file is the application that you want to run. So we're now on, we're done. Step 13 is complete. You're seeing removing intermediate container and so on and so forth. If you look at the images, I now have a new image named SQL 2017 CentOS 1.0, and it's 1.31 gig. Wow, it's relatively smaller than the default image or the publicly available images from Microsoft. And the reason why it's smaller is, number one, the images from Microsoft have the SQL Server database engine plus the SQL Server tools. Your ODBC, your SQL CMD, all of the tools that you need are installed on top of it. And let's explore this in more detail. Docker. We'll use the docker inspect command to look at the image that we just created. If you look at, I'm looking at labels. There we go. The labels. If you look at the labels, it gives me an idea of, the image that was based off of what I added in my Docker file. Okay. Docker. Looking at Docker history, it tells me the different commands 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You might be wondering, 15, what was added there? You have additional commands, like for instance, we're adding a file and then we have a label and then your commands. If you look at how the image was built, the Docker history command exposes all of those commands that were used inside a Docker file to build this image. Okay, so let's now create a new container using that new image. Oh, before I do that, I want to stop this. I want to stop that, and I want to stop so I can reuse. I'm lazy, so I can reuse port 1433. And here's what I'm going to do. I'm going to this. Here is what I'm going to do. Okay. Remember that container that we created where we added a new user database named SampleDB? It's still there, right? The database files are still in the volume. the volume is still there, and my database files are still in that volume. So what I'm going to do is I'm going to attach the volume to this new container that I just created. I call it LinuxCon 01. Now I'll call it LinuxCon 07. And I'm going to use 1433. Wait, host name, I'll call it LinuxCon 01. What I'm doing here is I'm simulating an upgrade. Yes, I'm simulating an upgrade where I'm upgrading the container from lower version to higher version, but I'm attaching the existing volume. Let's run this. Done. Yes, that was it. And if you look, SQL Server is now ready for client connections. That was fast. Let's connect. By the way, this container is done because we killed it. We deleted it. So if I, even if I do a refresh, that's going to time out because it doesn't exist anymore. So I'm going to connect to this using the default port. By the way, I already have one that uses the default port number. I'm just going to refresh that once this thing is done. And now I have an existing container using the custom image that we just created. Yep, timed out. So here's what I'm going to do. Since this one is using port 1433, just going to refresh it. 3076 is the version that 3076.1 is the version that I'm running previously. Refresh 3257.3. That was an upgrade, wasn't it? Now it's 14.3257.3. And I refresh this, look at the database. It's there. The databases. It's there. And if I do a SP help DB, the databases are there. Database files are there. The data in the log file is there. And they're all on those locations. I simply did an upgrade like that using a custom image. And if I look at the version, it is no longer running on Ubuntu 16.04. It's now running on CentOS 7. So now I built a custom SQL Server on Linux image running the Linux flavor that I want, the Linux distribution that I want. And if I want, I could, deploy scripts on top of this. You could restore backups if you want, to create your own custom image. And what I've simply shown you is creating a custom Linux image. I don't want to show you how to do the Windows side because, for one, it takes a lot longer. But if you're interested in looking at the Docker file for Windows, here's how it looks like. Some of these might look familiar to you. I might be wondering, what is this? I'm creating a new directory named SQL 2016 dev_sp2 because the way you install SQL Server on Linux is not quite the same as the way you install SQL Server on Windows. In Windows, you got to download a file, extract it, store it somewhere else, and then you install from there. On Linux, so long as you have the repo file and your machine has access to the internet, it will pull all of those packages from the repo and install it from there. Setup.exe, pretty straightforward. This is kind of like installing SQL Server from the command line. This command will simply start the SQL Server service using PowerShell. And because I don't need the installation media, I'm going to remove it afterwards. And this is the fun thing here. Fun thing is because this is unlike a Linux executable, you have to do something in order for the container to not terminate whatever process is running and run stuff on the background. In this case, it will run start.ps1. This is a script from the Microsoft product team. And if you look at what the script does, it's quite interesting. I'm just going to show you the last section of the script. This is simply going into an infinite loop to run the script so that it doesn't terminate the container. That's all it's doing. Right? Update, add seconds -2, while true, of course it's always true. Get event log, get date, sleep, seconds seconds 2. And again, the idea behind that is once you're in a container, you need to have the application running. Now, in the Windows world, it's a service. Run the service, it's running in the background, but what happens to the command after you start the service? Nothing. SQL Server's running, but there's nothing else that's running. In Linux, it's about making your application, in this case, the SQL Server executable, to be the last command running so that the container doesn't terminate. Because when the container terminates, well, it's like shutting down your machine. Okay. I wrote a 6-part series article on MS SQL tips last year on, getting you started, getting deep into creating custom images, custom SQL Server on Linux, custom SQL Server on Windows, image that you can deploy in production or dev test. By the way, there's a specific message from Microsoft that says they don't support deploying SQL Server on Windows containers in production. Kind of weird coming from Microsoft. But it's also one of the reasons why I try to show as many examples as I can using Linux, because moving forward, Microsoft's not going to support deploying SQL Server on Windows containers in a production environment. So yes, have a look at those series of articles on MS SQL tips. I'm actually writing a book on SQL Server DBA's Guide to Docker Containers. Hope to get it done by the end of the month. Writing, and then the editing goes after that. But the idea behind that is, again, to get DBAs to get started with working with containers, just getting started with the whole DevOps thing, because again, the developers are already way ahead of us when it comes to working with containers, the whole DevOps CI/CD practice, and we're left behind. We don't want to be in a situation where they're taking over our jobs. I mean, there's nothing wrong with that so long as they're doing it right. But you know how it is. People who don't have any clue about how SQL Server works, and now they're managing SQL Server, deploying databases, managing databases. The idea behind it is that containers plus DevOps, or containers is just a great tool, make DevOps easier. It's just one of many tools. And since you've created a custom Docker image for your SQL Server instances, you can tell your developers, this is the image that we're going to need. Or if you want, you could incorporate that into your CI/CD tools, your deployment tools, and let them run with it. If they want to make some modifications, tell them to request for a new image. Maybe incorporating some of the changes they want, maybe updates to the schema because of a new feature in an application. Now that you know how to make or create new custom images, you could incorporate that in their deployment practice. I want to open up the floor for questions. I know Kevin asked a question about persisting data. I've answered that question. If you have questions, feel free to type them. And if you have insights like, oh, I think I can use that at work, I'd love to hear it.
All right, got our first question. Do you have samples of a Docker Compose YAML file to model environments?
Great question about Docker Compose. One of the reasons I try not to use Docker Compose and focus more on Docker files is coming from a SQL Server DBA background. It sometimes becomes overwhelming just looking at tools, like even navigating the command line interface for the Docker client. It's kind of a bit overwhelming. Docker Compose and YAML files are designed, well, not designed, but they were originally written for developers. I've built a few YAML files in the past, deploying SQL Server on Kubernetes. But again, I'm always putting my DBA hat on and thinking about how would a SQL Server DBA with no Linux background approach this? Would it be would it be intimidating? Would it be something that they would easily approach? That's why I try to keep things as simple as I possibly can. In fact, you saw me use WinSCP instead of creating the Docker file inside the Linux machine using VI or any of the built-in text editors on Linux. And again, it's the idea behind it is to get SQL Server DBAs into just trying it out. Plus, my biggest pet peeve with YAML is one wrong character. It's like XML. It's very sensitive to that. So I even try to use different parsers just to make sure that the YAML files that I write are proper, so that when they're interpreted, I'm not spending time troubleshooting something when it's just a simple extra space or a simple character that I fat fingered as I'm typing. That's why I don't use a lot of YAML files, but I'm trying to recall if I have one specifically for SQL Server. I do have one for I think for Kubernetes, but I have to look for it. I haven't touched it in a while.
Okay. Do you have any recommendations on network mapping tools for like what your container infrastructure looks like and where they're sharing data?
Great question. So the question was any recommendations on network mapping tools. So I'm guessing this is mapping for instance, port numbers plus building your Docker host in a way where if I'm using a storage area network, specific NICs are mapped to those versus containers mapped to public network where the applications are connected. The basic TCP/IP rules still apply. The basic network design and configuration still apply. They're no different from how you would provision a virtual machine where you got multiple network adapters, one of which is mapped to your public network, while the other is mapped to backups if you're taking snapshots. All the TCP/IP recommendations apply. It's interesting you asked that question because when I did this pre-con, I did this pre-con at the PASS Summit a couple of months ago, and the same question, how do you configure this? And I said, the biggest challenge that we have learning new technology is thinking that we have to forget the old lessons that we've learned. No, they still apply. In fact, one of the reasons why I keep reusing 1433 is because, number one, I can't run multiple containers using the same port number and expect everything to work. Right? If you're in an enterprise or an enterprise organization where even opening and closing port numbers would require a change management request so that your network engineers could open up those firewalls using firewall rules, then you know what I'm talking about. So those things don't change. They still apply. TCP/IP rules apply. Network configuration best practices apply. If you're going to use a specific network adapter for your Linux host or your Windows host, and you want that specifically for replication or public traffic or network traffic, it's the same approach as when we were dealing with virtual machines with physical machines. They don't change.
Okay. Is there a preference for bind versus mount for SQL with the idea of, like, think log shipping?
So the question was the difference between bind and mount. I'm guessing the question has something to do with Docker volume.
Yeah.
No, although moving forward, bind was the recommendation initially from Docker, but moving forward, they want everyone to be using mounts. But the way I look at it is also understanding what your underlying network infrastructure looks like. It's also understanding what your underlying storage infrastructure would look like. Again, Docker might have recommendations on this. From what I've seen out in the field is, again, using the appropriate approach given understanding your underlying infrastructure. One pet peeve I have is, just following best practices and recommendations blindly, just because Microsoft says so, just because a storage vendor says so. They would make those recommendations as best practices, but they don't know how your environment looks like. They don't know what your compliance or security requirements or corporate requirements are, what your infrastructure looks like. So I usually apply best practices and filter them with my understanding of, what does my network look like? What does my infrastructure look like? What does my storage subsystem look like? And what are my corporate security or compliance requirements? Right? So whether it's bind or mount, there's some recommendations from Docker, but I would always filter those recommendations based on what I know about my environment.
Okay. Next question here. Could you run more than one instance of SQL Server within a single container?
Question is, can you run more than one instance of SQL Server in a single container? The fact is, on a Linux operating system, you can't have multiple instances. You can only have one instance, and it has to be default instance. Which also means, because you're basically just running SQL Server on Linux but on a container, the same limitations apply. You can't have multiple SQL Server instances on a container. Although on Windows you can, right? Because it's just a matter of installing SQL Server twice. But the question there is, which port numbers are you going to expose? Because now you're dealing with multiple instances and multiple port numbers. So which one are you going to expose?
Okay. Have you seen SQL Server containers in production environments?
Great question. One of my clients is actually doing a POC on that. There aren't a lot of big customers at the moment that are deploying it in production. Mostly are doing it in dev test. The one client that I referred to, they're one of the largest security companies, and I know a little bit of a history on their quest or their journey towards this. In fact, a couple of years ago, they approached me to help them out deploy SQL Server availability groups on Linux. And they're a big Linux shop. They have Linux engineers. But the question I had for them was, how many people on your team know Pacemaker like the back of their hand? I said, nobody. Then don't. Because at the end of the day, it's not about, deploying it on a specific platform or, having, the skill set. It's about, can you support this moving forward? And so, again, going back to the question of, have I seen customers or large customers deploying it in production? Not a lot. But again, that's just the way it is for most customers. I'm not going to deploy RTM, like even when SQL Server 2019 came out. I'm not going to deploy RTM. I'm going to wait until a few more CUs. But that's just human nature, right? It's been like that for years. The reason that I've started doing this, and the reason I've started doing SQL Server on Linux and SQL Server on containers, is how customers evolve throughout the newer versions. I remember the time when always on availability groups came out in 2012. A lot of customers didn't really pick it up until between 2014 and 2016 versions, and that's just because, again, the way of thinking of we don't want to move things too quickly, or we want it to be stable enough before we can move it to production, or they're just waiting for other customers so that they can have a really good case study to refer to. But at the end of the day, it's going to come to a point where these are now the new standards, the new standard for deploying SQL Server. The question is, are you ready for it? Right? Again, just seeing where Microsoft is taking SQL Server when it comes to Linux. Most of their examples nowadays are now focused on Linux. The documentation for Linux, the implementation, now with Kubernetes, they're standardizing on this. So, and the fact, of course, that you're seeing statements from Microsoft that, hey, we're not going to support SQL Server on Windows containers in production tells you so much. And that's why even if customers are not deploying it in production, I highly recommend that you start playing around with it. You start testing it even in production. Of course, not going live without the proper testing to make sure that it meets all of your requirements. But at the end of the day, again, this is going to be like the virtual machines of the next SQL Server era.
So if I unfairly tried to nail you down on a particular time frame for this, do you think it's this year or within the next year or so, or are we talking 2 years, 5 years, 10 years?
I'm going to put my business hat on. I'm going to say this year to next year, because keep in mind, when you're talking to CIOs, to CXOs, they're hearing messaging from Microsoft, and they're hearing 2019 because SQL Server 2019 was recently released, right? So thinking that, hey, I'm going to move my stuff off of 2016, I'm probably going to move to 2019 now and skip 2017. And because 2019 is recently new, I'm not going to put stuff in on 2019 just because. I'm going to wait until they release CU12 or CU14, right? Again, it's just the nature of, people making those decisions based on challenges that they have. Like I said, anytime later this year, because by then it's about 1 year after SQL Server 2019 and early next year.
Okay, that's a fair answer. Looking to see, looks like that's all of the questions I'm seeing in chat here.
Oops. And if you do have questions, follow-up information, send me an email. I'm on LinkedIn, on Twitter. I'm happy to respond to those questions. Like I said, I've also provided additional resources from MS SQL Tips. Got a 6-part series article on getting started with SQL Server running on containers, both Windows and Linux. Although I spend a lot of time on Linux, again, just because of how Microsoft is driving the development of SQL Server towards a Linux platform.
Great. It looks like we have one last question here. Do you use a remote monitoring tool for Docker?
Do I use a remote monitoring tool for Docker? A few of my clients are. They started using, one of my clients started using Nagios for their monitoring. The idea there is, how do we actually incorporate some of the lessons that we've learned from monitoring operating systems and platforms, and not just target the container? Because again, don't fall into the trap of thinking this is a new technology, we need to learn something new. No. Take as much lessons as you've had from, doing stuff in the past and incorporate them in there. So basically, if you want to monitor SQL Server on a container, it's the same basic stuff. But you're not going to be monitoring disk space in a container because there's no disks. There's no disk in there unless you want to monitor the volume, but that is monitoring the underlying operating system. But the idea behind that is, again, concepts that the lessons that you've learned for monitoring operating systems and applications, they still apply. It's just a matter of finding the right tool for monitoring the platform that you
Awesome. Thank you very much. You're getting a lot of thank yous in chat. Great cross-platform presentation. Great presentation. Great session. So thank you very much.
And thanks for having me. I really appreciate you opening up your user group for this. Thank you.